All right, as we always do, let's make sure we label this. Unit 11, gas laws. All right, let's recap on yesterday's. Let me put a little bit out of focus. Sorry about that. There you go. Let's recap about the previous lesson. We spoke about Boyle's law, and I am referring to who discovered it, but remember that's not the big focus. The main focus on is what variables, like what the relationship between the variables are. The relationship between pressure and volume is Boyle's law. So let's write out his equation. I'm going to box it in. So we just have it as importance. Things that we learned about this relationship is that temperature is considered at constant, so it's not changing. So although temperature may be mentioned in an equation, it may state that we are at 25 degrees Celsius. Well, that's room temperature. So although you state it, if you're looking at it written wise, although you state it, if there's no changes, then we're looking at a relationship between pressure and volume. We'll be able to calculate one of these variables. This relationship is considered indirect, sometimes referred to as inverse relationship. What that means is as volume increases, your pressure decreases, or vice versa. Okay, so as one goes up, the other one goes down. That's what an inverse or indirect relationship is. One thing I want to add today are possible units that you may encounter for all the different variables. And let's start with pressure. Pressure has quite a lot of variables or units that can be used. So units of pressure, let's list those. One that you may have heard of is considered or is called PSI, pounds per square inch. That's not one that we typically use in chemistry often. However, that device in the demonstration had pounds per square inch on one side and something called kilopascals on another. So now I'm stating what they are, but I'm giving you the units, the symbols units. If you can have kilopascal, then you can have a pascal, which is PA. Something you may have heard of if you've ever listened to the news and they talk about weather. No problem. So something that you've heard of, the atmospheric pressure, ATM. We're going to talk about something called standard temperature and pressure. We've actually done standard temperature. The standard temperature was 273 Kelvin. Standard pressures, it depends on how elevated we are. In Darien, Hinsdale, Willowbrook area, Lockport, Homer Glen, we're at 1 atmospheric pressure. Okay, so we're going to talk about these standard temperature and pressures next week, and we'll be referring to them in units. One that we use more often in chemistry is mmHg, which stands for millimeters of mercury. In physics class, you may have heard of something called a torr. You may not have yet. However, in some physics classes, they'll start talking about torrs. So I'm going to asterisk the ones that we tend to use more often in chemistry. However, these are all the units of pressure, and there are more, but I've just listed a few. Temperature, let's go through the units there. We learned from last unit that the temperature to be converted into standard temperature is to add 273 to our Celsius, and that gives us something called Kelvin. And I'll put the symbol of Kelvin. We've used that already. There's no degrees Kelvin, it's just Kelvin. So to solve any of your gas laws, you need to make sure that you're using Kelvin, the International System of Measurement and Temperature. If it's in Celsius, you convert it into Kelvin. Okay. Let's go to another variable. So we had pressure, we have temperature that's held constant so far, but we are going to be utilizing it today. And then we have volume. Let's add that in. Possible units for volume. We could have milliliters, you could have liters. You may have something called centimeters cubed. So I put that next to each other because milliliters and centimeters cubed are the same value. So if you had 2 milliliters, it's 2 centimeters cubed. All right, so we have different units. And of course, there are more. These are ones that are widely used for chemistry class. So let's begin on adding our information for today. In the one demo, we saw a data table because we took the temperature of the water, and with the pressure gauge, we then recorded the amount of pressure at that certain temperature. The results were as follows. At 1 degree Celsius, we had 80 kPa, kilopascals. And I believe the student that wrote this on the board for me at the time just wrote kP, but the actual unit is kPa. At 23 degrees Celsius, we have 92 kilopascals. At 76 degrees Celsius, we had 115 kilopascals. So let's take a look at the relationship between temperature and pressure, these two. There's no mention of volume, and the volume of the water was pretty much held constant, so we'll write that on the side. Volume was constant. Let's look at the relationship. As our temperature increased, you'll note that our pressure was increasing as well. This is considered a direct relationship. As one increased, the other increased directly. The scientist's name was Guy Lussac, or properly pronounced Guy Lussac. So this direct relationship is what he discovered. But again, we are focusing on the relationship itself, less on the scientist who discovered it. So with this direct relationship, we have a different type of equation that's going to result. Pressure, as one increases, the other increases. So then we can set up the other portion. As one increases, the other increases. I'll box that in so we have that as our next equation. I do want to add a graph since we showed you graphically what it would look like if it was indirect with Boyle's law, pressure and volume. Let's take a look at the graph that would be produced from a temperature pressure. Draw the graph out. I'll label pressure on my y-axis and temperature for my x. And now instead of an indirect relationship, we are a direct relationship. So the graph would look like this. As one goes up, the other one goes up. As one goes down, the other one goes down. And these two constants, or these two variables, is what I'm referring to. So we still now have to see what happens between our volume and temperature. We haven't compared those two variables. What happens with gases when we're looking at volume of a gas and its temperature? And this is kind of like a balloon, right? When you buy a balloon at Party City and it's either really hot or really cold outside, what happens to that balloon? Well, let's look at it. I'm going to scroll myself down here a little bit. Place that up here. All right, so we have a volume versus temperature relationship. So if we're dealing with these two variables, we are considering pressure to be constant. And this is where in an actual problem, it might state that you may be at 1 atmosphere. Well, that means you're in Darien right now, and you're at Party City, and what's happening to your balloon if the temperature is either hot or cold? What's happening to the volume of the air in the balloon? So there is a direct relationship between volume and temperature. Direct relationship. Okay, so as my temperature increases, my volume increases. Or we'll write up the next part. As my temperature decreases, my volume decreases. Let's box that equation in. I want to make note of what scientists discovered that. So we call that sometimes Charles' law. And let's make a short graph there, or a little graph there, to show ourselves what a direct relationship looks like. I'm going to use volume on my y-axis and temperature again on my x-axis, and my graph would look something like this. A direct relationship is one increases, the other increases, and vice versa. Now I've included what happens with all the relationships of those variables in terms of gases. But there is something that occurs if there's nothing held constant. So I'm just going to combine them and call them the combined gas law. There's no constant. So if all the variables have changes, you have your pressure, your initial pressure, your initial volume, your initial temperature, there's changes that occur, you can solve for one of the variables as long as you know two of the changes. So looking at our equation, you had originally this equation. Pressure, volume, this indirect relationship. And then I introduced a direct relationship between pressure and temperature and volume and temperature. This should be a 2, sorry. Pressure and temperature and volume and temperature. So combined gas law is just that. It is combining your variables, pressure, volume, and temperature in an equation. So right now I'm going to stop the video, answer any questions so you can have some time to practice.